Awesome. So today we're having Jonathan Beri. I always start with some fun fact about people. So we've known each other for 10 years now, and today I looked at your LinkedIn and I saw that you worked at MySpace, and I didn't know that. That's amazing.
That was many lifetimes ago.
Yeah.
Actually, my first gig in developer platforms. So that's very apropos for this conversation.
Yeah, definitely. So maybe that's a good start. Let's introduce yourself, and then we can talk. We're going to talk today about hardware and IoT, which is your favorite topic and what you're doing today.
Yes, yes. Yeah, so Jonathan Berry have been working on developer platforms my entire career, mostly external platforms, some internal, and learned a lot of lessons along the way. I even worked in developer relations as part of my career, which was equally fun. Been, as Amir mentioned, from everything from gaming platforms, mobile platforms, enterprise software, but for the last almost 15 years now, focusing more on hardware developers and hardware platforms.
That's awesome. And we worked at Google together, and you ran
Yes.
some of the IoT efforts there, which was awesome to
Yes.
see.
Yeah.
Okay, so what is like fundamentally different if you're building like a software platform like Android, in terms of like in contrast to building a hardware platform for developers like Arduino, for example.
Yeah, yeah, that's a great question. Developers and developer platforms, regardless of the domain or industry, share a lot of similarities. Hardware is hard because the tools actually. That's probably the biggest difference. If you're developing a web app hosting platform like a Vercel or something, someone could just go to a website, download some stuff, and try out your platform right away. Well, with hardware, they need the physical thing. And not just the fact that they need the physical thing, like a development kit or a programmer. The software tool chains to go along with that are also challenging. One of the complaints you'll hear often is the developer tools for hardware developers are 20 years behind the rest of software, which is getting better. But that means if you're building a platform, not only do you have to make sure they have the hardware you work with or you're building, or figure ways to build simulations for that. You also have to build tools, and likely you have to build your own tools for developers to get onboarded, to try out your stuff, to deal with issues. And so there's an extra burden of complexity because of that hardware component and the tool chains and developer tools and experiences around working with hardware.
It also feels like the tools are not as mature as software. I remember we've done a Google Glass workshop with developers a while back, and we brought all the game developers to integrate into the Google Glass, and we spent half of the day just getting the setup to work and having like the hello world didn't work.
Yes, yes. That's kind of the key pain for developers building hardware. The time to hello world is so much longer because of do they have the right device? Are they on a Windows or are they on a Mac? And does the tool chain only work on X, Y, or Z? I've done a lot of developer trainings, and doing a hardware focused developer training is actually the most complex. So much so that most companies, peers, partners, etc., will oftentimes just bring laptops pre-programmed with everything set up and the hardware, so you can go through the training. And there's still complexity of learning those tools and whatnot. We actually run virtual online trainings, and we require everyone to come to bring their own hardware. So they have to buy the hardware that we've tested and validated and made sure. But at least we can do some things these days in the browser. So like we use GitHub code spaces for a lot of the development, but then they still have to have some stuff on their machine, which adds a little bit of complexity.
So, and this is a little bit of a plug into your startup. Hardware also has a problem of connecting into services that you have in the backend. So, for example, if I have a set of services or APIs in the backend, connecting that to a device, it's pretty hard.
Yeah, yeah, and so my company Goliath is focused on IoT and creating smart sensors, e-bikes, concrete, which is a fun side topic. But that's not the only kind of connected hardware. We overlap, but different developer audience for things like robotics or medical devices. And the The extra challenge is so hardware, programming the hardware, debugging the hardware. Then you have services that you're trying to connect that hardware to, whether it's IoT services or robotics command and control. And so it just makes the problem for the developer trying to build something in this space even harder. And I would also argue of a place for companies to come in and kind of smooth out that with a better developer experience, with better developer tools. You know, just like in a lot of areas, things like SDKs and documentation and example projects are so critical. Now, when you have hardware plus cloud software, which has all these places they can fall apart, you rely on that even more. And so that's where we spend a lot of our time is building that integration, the simplification, because that's the hardware still hard.
I've seen some companies, Google and Apple, that create emulators for the hardware. Do you think that that's a viable strategy if I'm like opening a new platform for hardware to start doing spend time on emulating?
Yeah, so in the world of hardware, there's the equivalent of tabs versus spaces, and real hardware and simulated hardware is like one of those things. For example, if you're designing electronics, there are some parts where you actually use simulation, but for very specific, physics. But for the most part, you really can't simulate building your thing. You can do it in your CAD software to help you design it, but until you actually make the thing, you're not going to know if it works, and then you're probably going to do a lot of working. Now, in the world of writing software for hardware, so what we would call firmware engineers or embedded engineers, they actually use a lot of simulation. There's some great open source projects, a lot of virtual machines. Depending where you sit on the stack, it actually is a really powerful tool. We use it, and our customers use it. There's a lot of open source tools that make this possible, but it's again not always the right enough, right? So, for example, in Android Simulator, right, you can simulate the GPS, you can simulate, the motion, but if you're designing the sensor, that's not detailed enough. It's not actually modeling the physics and all those other pieces. And so you see simulation being used for kind of higher level parts of the space, but in general, that's sort of tabs versus spaces. Unless you're an application developer and a very specific part of it, you really got to have the real hardware. Now, the other thing which I haven't really touched on yet is just the sort of the dated part of tool chain. Things like version control, things like simulation, things like continuous integration is present, but I would say it's actually pretty rare. And I was surprised about that, coming from Google and Nest, where we had very mature test infrastructure, test engineers for both hardware and software. The most of the industry doesn't adopt it. And so it's actually a challenge for developers and companies adopting these modern tools. But those who do, it's great, right? Like I can do a git push on GitHub, run a GitHub action, and literally deploy new update with all the checks already, but that's pretty rare. So things like simulation, things like even coding assistants and other things, while they do exist, it's not as dominant as it is the rest of software development, which is
And you're talking specifically about the software development rather than like the firmware updates, right? That you see on like watches and stuff like that.
Yeah.
Like
So
actual development.
yeah, so this is like a typical. This is a Bluetooth sensor board, and so the software that's running on here, it's probably written in C or C++, and it's using a bunch of libraries. It is very common to develop it on your machine, maybe check it in, maybe into Git, maybe not, and then have other engineers test it, program a bunch of devices to verify it's doing what you think it's doing, and that's the kind of the general best practice. Yeah. I say that, but your wearable, your smart home device, any robot that you see in a factory floor is probably going to be using, all the best practices in testing and test-driven development. What's a common thing for CI/CD is actually what we call hardware in the loop testing. So you have physical boards connected to like a Raspberry Pi or some other machine. It goes through a battery of tests with real devices, but not a human pushing a button, which is great. And then check it into Git, validate it, push it over the air, and then that goes down to your device. That's probably how our modern tools work. That's certainly how we build things at all the companies I'm at, and what we work off with our customers too on.
Interesting. Um, with all these challenges that you're talking about, it feels like it's really hard to scale. So if I'm building a platform for hardware, like let's say we're not launching the next Arduino or the next API gateway, like how do you scale your engagement with developers?
Yeah, I think it will depend on which slice of the hardware world we're talking about. Uh, the most recent stat I've seen is that there's 4 million hardware developers in the world, which I thought it was a little bit higher, but doesn't surprise me. And so it's actually a much smaller
Small.
pool than other developers. And that's specifically embedded developers, so the ones who write the software for them. There's even smaller, fewer electrical engineers designing electronics. And smaller pool within specific niches, they kind of cluster together. So people who work on cars and automotive hardware tend to be highly specialized and use highly specialized tools and have tool chains and ecosystems versus people who work on robotics versus people who work on drones versus people who work on IoT. And so it really would depend on that sort of industry. If you're building robotics, right, for example, there's probably only 50,000 companies or give or take that could be a customer of yours. And that means there's only 50,000 or maybe 100,000 potential developers who would be using your stuff. So you create a very different kind of developer experience, very much focused on robotics, but also for those 100,000 developers. If you're working on sort of like more broad IoT sensors for consumer, for example, there's a lot more of those 4 million. But then you have to take a different approach to which partners you work with, which tools you incorporate, which tools you build, because that looks more and more like a mobile developer ecosystem than it is sort of a more niche auto or robotics. And so it actually is not a well-charted path to build a developer platform for hardware developers because it actually is pretty complex.
And what I'm hearing from you, which is interesting, is that this is not it doesn't feel like a community effort. It feels like a top heavy, like find the partners. If you're doing something for cars, go to BMW, go to Honda, go to the top partners and get them excited and then move to maybe a broader audience of developers.
Yeah, and the partners could be, for example, the chip manufacturers. So we work with all the chip manufacturers who build components that go into IoT devices. There are similar ones for auto, but there's other parts of the ecosystem. Now there are communities, and there are developer communities, even kind of in this sort of like smaller group. And actually, open source has created that. Prior to open source, there really hasn't been a lot of community for hardware developers. It's actually been a very insular industry. A lot of it is because of proprietary software, company secrets. And when we worked together at Google, 10, 12 years ago, there was very few projects that were open source related to hardware. FreeRTOS was probably the earliest in the IoT space and the hardware software space. Since then, there's been a proliferation, and more of the hardware developer ecosystem is becoming open source, and there's actually communities around that. The one that we've been involved with, and I've been involved with for the longest, is under Linux Foundation called the Zephyr project. It's an open source operating system. It's vendor neutral because it's part of the LF, and what the chip vendors have realized is, well, they can build their own proprietary stuff and try to sell developers and build tool chains and IDEs, but that's not what people want. So instead, they're shifting towards using VS Code and running open source VS Code plugins, supporting and maintaining components in this upstream open source project. And it's that place where we're seeing the biggest communities develop around hardware developers. Specifically Zephyr as an example, but there are other ones like it. And this is one of those shifts because of open source has commoditized a lot of the stuff that people were trying to make proprietary, has allowed communities to start to form over the last decade or so, which is
I love
really
it.
fun to watch.
It seems like it's a little bit late in the game, right? Software did it like 40 years ago, and now hardware is doing that. But it's good to see.
Yep, yeah, yeah, and it's there's this sort of niche industry. Again, 4 million is 4 million plus or minus is not nearly as big as pretty much the next other categories of developers, but it's meaningful, right? And
Yeah.
a lot of it is key parts of business. Developers on hardware control a lot of the business decisions. So arming your developers with right tools and purchasing is the same as we see in software and cloud software and mobile tools, etc. But it has some of those factors. The tools are a little bit behind, so the ecosystem is not that great. We're catching up. Another category, which is kind of all the buzz today, is using AI to improve developer productivity, and it's also a challenge. If you use a common coding assistant, like a Claude Code, and it's trying to get better, and 3 months ago we saw worse performance than we do today, so it's rapidly improving. But you have to think about, if most of the software that's running on the devices around us are proprietary, then how can you train your data sets on proprietary data? So there's some startups now, some YC batches that have gone through that are trying to take this same lessons from coding systems for web and mobile and bring it to embedded, but those are pretty niche, and so we don't see that fast adoption as we do in the rest of software development.
And do you think I've heard about AI at the edge, so like AI at the IoT level, at the hardware level? Do you think that that's a trend that we're gonna see getting stronger?
Yeah, it's accelerating. If you go to any of the trade shows 5 years ago, and we're going to the first major global trade show, it's called Embedded World in Germany. Every booth had AI at the edge, on a device. It was monitoring some sort of a pump or some wearable for fall detection, and it was all vaporware. It technically worked, but it was not useful. No one was paying for it. And I went last year, and it was all customer use cases and customer scenarios. So we're really seeing this massive acceleration. A lot of it's actually driven by mobile. So Google and Apple have really developed on-device AI for powerful phones. Well, so now those sensors, which may be less powerful but still increasingly more capable, are able to run AI on those devices. And there's whole ecosystems, actually, a bunch of companies who build the tool chains, the cloud compilers, the libraries and kind of models specifically for edge AI. And so you see massive, massive investments. Qualcomm, for example, has a bunch of companies under its umbrella that they've now integrated to make it easier to run computer vision on a phone-like device or even smaller. And that's part of their developer platform. And it's really cool to see. I was surprised. We enable edge AI, so being able to take a picture on a device and understand what that subject matter is, and if it's relevant, send the information to the cloud, and if it's not, just log it.
Drop it. Yeah, that's
Yeah.
very useful.
Batteries, a lot of the use cases might be like a drone on 5G. Well, everything you send to the cloud costs you money, so be smart about it. And that's one of the ways. That's one of the factors of driving edge AI. Now, going back to those poor developers, they have to learn about hardware and crazy tool chains and now cloud connectivity and edge AI. It's actually a very complex ecosystem to be part of, and just rapidly changing things that are new to an industry. It makes it even harder for developers to be productive.
So, last question. This has been a very interesting and very different way of thinking about developer relations, because you actually need the device in your hand.
Yep.
What is the future of this industry and developer relation in this industry in general?
That's a good question. The trend line that we've been talking about, right, where tools are getting better, more modern best practices for software and hardware development are seeping in. Open source is dominating and becoming increasingly dominant across the industry. AI and AI coding assistants, as well as edge on the AI, it's kind of converging. A lot of those complex tools just become super simple. I think the commoditization and simplification in the rest of software, it took 40 years, is happening, and it's accelerating at a faster pace because we have these capabilities. It's amazing to see how productive non-formally trained engineers are today building web apps and business applications. I don't, we're not going to see that tomorrow, where someone who never studied engineering is going to build the next thermostat, but it's trending in that direction. And so in the near term, we're seeing developers building hardware being more productive because the tools are getting smarter. AI is starting to be a little bit more helpful. Libraries and ecosystems with open source are simplifying the stuff they have to write to get to the proof of value. And so, I think developer relations right now in hardware is you got to know all the things, try to simplify that down shave off all the rough edges, where it's going to be more about creating more integrated capabilities. Making the devices smarter, making the devices do more, making the devices be more efficient, because you're not spending all this time of like, does this thing even blink? And you're spending more time on, what is the novel use case I want to build. And so the platforms will adjust and sort of create higher level kinds of ecosystems and tools. That's what I see.
I love that. I have like the Whoop here, the WeThing watch here, and the Apple iPhone headphones. So I think like it's gonna take a big part of every type of our life. Everywhere we're gonna have smart devices around us. So
Yes, yes.
that's a good promise that you're providing. That it's gonna be much easier for developers to build towards that.
Yes, I've been living and breathing this space for almost going on 20 years, and I want it to happen. So I will continue to focus on that and have fun doing it.
Awesome. Thank you so much for joining us.
I mean, always a pleasure.